Welcome to the FAST Lab. My name is Addison Petty. I'm a student geospatial consultant in the Facility for Advanced Spatial Technology and a Master of Urban and Regional Planning student at CU Denver. This video lab covers how to project your data in Esri's ArcGIS Pro by selecting the correct spatial reference for your project. When we talk about projecting our data, we're really talking about coordinate systems. Different coordinate systems distort data differently. In this map of the United States, you can see that 3 different projections were used to create 3 different shapes of the same United States. A geographic coordinate system defines where data is located on the 3-dimensional surface of the Earth's globe. A projected coordinate system defines how that data is drawn on a flat surface like a computer screen or a paper map that you might need to print. If you're working in the Urban and Regional Planning program, for example, you're most likely going to be working with projected coordinate systems, or PCS, that are measured using linear units like meters and feet. This lab will cover how to set the spatial reference for your project layers and maps. And the important thing to remember is that the coordinate system for each of your map layers should match. The projected coordinate system for this video lab is known as well-known ID 6428. That stands for the Colorado Central State Plane measured in US feet. This is a common projected coordinate system for urban and regional planning in Denver. We'll cover how to reproject shapefiles to an alternate coordinate system in ArcPro, and we'll be working with some practice data for municipalities and census block groups. Let's get started together in ArcPro. By default, data in ArcPro is projected on the fly. This means that the data frame is automatically projected on the fly to match the spatial reference of the first data layer that you add to your map. Let's start with municipalities first. Here we can see that our data is projected, meaning that we can see it on the flat surface of our computer screen. To check the projection of this data layer, you want to right-click on the layer, select Properties, then select Source, and expand the Spatial Reference tab. Here we can see that this data is already projected properly. It's projected in well-known ID 6428 for the Colorado Central State Plane measured in US feet. Now, we always want the projection for our layers, our map, and our project to match. So in the Project tab, you can go to Options, select Map and Scene, expand Spatial Reference, and here you can see that the default setting, again, was for the data to be projected on the fly using the spatial reference of the first operational layer. You also have the option to choose your spatial reference up front before you've even added any data at all. To do that, you can enter the name of your projected coordinate system or its well-known ID. So I'll enter 6428, and Colorado Central State Plane measured in US feet pops right up. You also want to make sure that this box is checked on. Warn if transformation between geographic coordinate system is required to align data sources correctly. We'll come back to this in just a moment. For now, select OK. Now, let's insert a second map, and we'll reproject this municipality's shapefile differently. To do that, just select the Insert tab and choose New Map. I'm going to rename this map to 4759 because that's going to be the well-known ID of the projected coordinate system that we will change to in just a moment. Let's go back to our first map, and we'll name this map 6428. Now, let's reproject this data layer for municipalities. To do that, open the geoprocessing pane and type in project. In this case, it's the first tool that pops up. Project, it's a data management tool. Once this pops up, the input data set will be Muni 2019 that we've been using. I'm going to make sure that this is saved to my correct data folder. And I'm going to rename it Muni 4759. Then in output coordinate system, I'm going to enter 4759 in the search bar, and we see that we get a new projection. Here there is a box called Preserve Shape. Leave that checked off, and then click Run. It says that our projection is complete. So go back to our catalog. We're going to add our new shapefile and watch for a transformation warning in the top corner. Here it says that the data has automatically been transformed to the geographic coordinate system 6428 that we set earlier. This is because we set our spatial reference at the project level, meaning that a projected coordinate system 6428 extends to both our maps and our map layers. Well, how could we change this? Let's click over to our second map, 4759, and let's check the properties of our map layer before we've added data. Here, just as we suspected earlier, it's still projected in the Colorado Central State Plain, well-known ID 6428. Let's change that now to 4759. Select OK. Right away, we can see that the picture just of the United States is quite different. Now, let's bring in our shapefile for Muni 4759. And let's take a look at our two different maps side by side. To do that, you can go to View, Link Views, Center, and Scale. Then we're going to drag and drop this tab so that we can see them both side by side. And here we can see that our correct spatial reference on the left, 6428 for Colorado Central State Plain measured in US feet, is more elongated. You can also get even a little better picture by zooming on to a specific area of the map. Here on the right side, the park is much wider than on the left side, for example. Now, remember at the beginning of our project, we said that the correct spatial reference today is 6428. So we're actually going to get rid of our map for 4759. We don't need it anymore. And we're going to remove our reprojected shapefile from our original map. Next thing we're going to do is practice one more time reprojecting the data. So let's say that I wanted to add census block groups to my map. Notice I got a transformation warning again, which means that this data needs to be reprojected differently. I'll drag and drop my municipalities so they stay on top clearly for us to see. Go to the geoprocessing pane, select your block groups file, make sure that it's saved in the folder that you'd like. And I'm going to rename mine BG for block groups, well-known ID 6428. And select Save. enter well-known ID 6428 for the correct projection. Oh, actually it didn't save there. Let's try that one more time. All right, and notice again that preserve shape is ticked off. Select Run. It says that our projection is complete. Let's bring it into our data frame. And notice we did not get a transformation warning this time. I'm going to change the color here so it's easier to see, just by going to Properties and selecting any color that you like. I'll drag and drop our municipalities back on top. And it's always good to keep your table of contents clear. So we no longer need our original shapefile for block groups because it isn't projected correctly. So I'll just remove that. Now let's double check the property layers for our new block group shapefile that's in blue by going to Properties, selecting Source, expanding the spatial reference, and verifying that it is indeed projected in the Colorado Central State Plane, well-known ID 6428. If you've enjoyed this video lab or have any additional questions, student geospatial consultants are ready to help. Visit our website at www.clas.ucdenver.edu/fast.